So, who do we have here this morning? Why don't you start by introducing yourself and what you do?
I'm Jeff Meng, and I'm dev lead on the Windows reliability team.
I'm Paul Sliwowicz. I work under the base driver quality team on the IO manager.
And I'm Gerald Maffeo. I'm a reliability program manager and was working with Jeff and Paul on this project.
Okay, so what is IO Cancellation? What is this project?
It actually all started back when Jim Alchin back in 2002 commissioned a request that all applications should be always able to be terminated. Frequently would happen, or not so frequently, but frequently enough, it would happen that people could not terminate an application. They'd try to close it with the red X or off the task manager end task, and the process would not actually fully go away. It would appear to be gone, but it would not actually disappear. And when you tried to relaunch it, it would cause all kinds of problems. So Jeff and I were discussing this. I was running this task force and came up with a variety of scenarios as to why this might be happening. And one of the areas that we were pretty convinced that it was driver related. So we went and talked to the driver folks, and in particular to NAR, who's the IO manager. Paul Sliwowicz is manager. So he owns the IO manager in the kernel, and they basically said, "Hey, go away. Give us some proof that this is true, and then we'll take you seriously." So then Jeff and I launched. Basically, he did all the development. A special piece of software that we deployed, which was a special ad hoc thing to gather kernel reports or kernel data when you get an error report, a hang report. And Jeff, why don't you talk a little bit more about the design and everything?
Okay, yeah, like Gerald was saying, we believe a lot of issues for the app fail to terminate is related to drivers, but we don't have data. We don't know how often it's happening in the field, and we don't know why it's happening. So at time, we also don't have an effective way to collect data, because in order to know which driver is causing the problem, we need to have a kernel mode dump, right? And to collect the kernel dump is very painful. You often have to crash the machine or force the machine to crash, or you have to connect the kernel debugger, a manual process, which requires symbol, all kinds of things which prevent us from collecting data from real customers. So NAR, Gerald and myself and a couple others get into a room, and we discuss ways we can actually collect a live kernel minute dump, right? We come up with great ways and to collect that, and we actually design that, so incorporate that into normal application hand reporting. So when someone say, I want to report an application hand, they click on the red X. If the termination takes a long time, so these live kernel minute dump functionality kicks in, and what it does is actually collect the kernel stack of the thread, and also collect the IO request packet information and device objects and file object information, so we have enough information to know what is causing the problem.
So where does this debugger run this?
So
go ahead.
Why don't I pick that one up again? So what we did actually was decided to deploy this to an audience comprising actually two separate groups. One was an internal group of non-technical users within Microsoft. So these were finance people, HR people, and whatnot. And so we actually deployed the special instrumentation, or especially instrumented version of the operating system of XP, out to that group of about 2,500 people. We decided also that because that was probably not going to be representative, that we should do this also externally. So we actually created a special technical beta program just for this purpose, and solicited another 2,500 people who were external. Which was a good thing, because as it turned out, we found, in fact, very different behaviors between those two audiences. Most of the special reports that we received, and there was about 7% of all of the hang reports that we received, were actually, most of them were actually from the outside audience. Because they tended to run a much larger variety of drivers and whatnot that would have a tendency to hang.
So now you're collecting all this data. What is the data? What does it have to say?
So let me turn it back to Jeff, who do the analysis as well. So
So yeah, we got great data actually from that. Yeah, we got actually great data from that tech beta program, and it turned out we got like 40% of those issues were related to the mapper and redirectors, and also there are about 17% of them related to firewall drivers, and others like related streaming class drivers, CD, DVD drivers, and also antivirus drivers.
And we had a video driver in there as well.
Yes, we have video drivers there as well. So the key problem we identified, to categorize those issues, there are two types of issues. One is a use mode thread that is being blocked inside kernel because of kernel mode way. So the termination cannot be happen. It's being blocked. And the other thing is because of actually the driver does not support cancellation, right? So then we proposed we basically worked with NAR and PAL's team, and there's quite a lot of new improvement happening in the Longhorn. So I would turn to Paul to talk about those new things and he's adding into the Longhorn system.
Before we do, can I just interrupt or interject one thing? And this is the interesting thing about this is, as Jeff said, 40% roughly of these problems were due to the redirector. So if an application opens or tries to create a network file, it ends up going through this mechanism. And it turned out that these were essentially not cancelable because there was no mechanism in the IO manager, in the kernel, in other words, to support the cancellation of these create requests. And second of all, the drivers themselves, because there was no mechanism in the IO manager, never had to support this kind of create cancellation. So now I'll turn it back to Paul, who will give you more insight into that.
Right, so prior to Longhorn, the stuff we're working on now, the only way that a developer could cancel I/O was calling a routine at the Win32 level called cancel I/O. Basically, this thing has huge limitations. It only works on the current thread. It waits for all the I/O that you cancel to complete. So once you've actually canceled something, it sits there and waits. So if the driver doesn't implement cancellation properly, you're still stuck waiting for these I/Os to complete. To address a couple of these limitations, including the major one being creates, which are synchronous, which happen on another thread, we added a couple new APIs in the IO manager level and exposed these to developers at the Win32 level. The first one is cancel synchronous IO, which basically allows you to give a thread instead of a file handle. So for the original cancel IO one, you give a file handle and it tries to cancel IO on the same thread with that file handle. Now with cancel synchronous I/O, you give it a thread and it tries to cancel all I/O on that thread. So you have thread A, which is doing your creates, and thread B, which is kind of making sure everything is moving along smoothly. Thread B sees that thread A hasn't done anything in a while. Maybe there's a create sent out to the redirector, which now as of Longhorn supports cancellation. Thread B goes, okay, let's cancel that I/O and see what's going on. Calls cancel, and then eventually, hopefully, thread A will return. Instead of sitting there blocked forever. The second API is cancel IOEX, which is basically an extended version of the first cancel IO, but it allows you to supply both a file handle and a request to be canceled. So you can look for a specific request to be canceled. It also doesn't sit and wait for the request to be canceled, and it works on every thread in a process as opposed to one targeted thread. So using these two, I mean, the work to actually improve this stuff in the kernel wasn't too extensive, but the amount of power that it adds to the developer is huge. I mean, you can see before the huge limitations with just cancel I/O, and now you have these other two APIs. I mean, between the three of them, basically you're going to be able to cancel everything. That said, like Gerald mentioned, a lot of drivers still don't support cancellation properly. We had a couple talks at WinHec and Driver DevCon where we were trying to evangelize cancellation to these driver writers. There's a lot of decks out on the web now about how to do cancellation, some different guidelines for cancellation. I'll turn it back to Gerald to talk more about some of the problems that people have had implementing cancellation and some of the stuff we saw.
Yeah, a big part of that problem. A big part of the problem we have is that cancellation is inherently a very difficult thing to do correctly. There are very significant race conditions that it can occur. In other words, you can actually, for one thing, the act of cancellation itself is a race with potential completion of a call. So, in other words, the call is in process, and it might actually complete correctly at just the time you issue the cancellation itself. Another problem is synchronization becomes very, very difficult, and if you don't do it correctly. So as a consequence, there are a number of papers that were written over time that led to, here's how you should implement cancellation and avoid these very tricky race conditions that can occur that can cause your driver to get to fail. So that was one thing. Another is at the same time there was a development in the IO manager team for a thing called cancel safe queues. And this was the recommended mechanism then for implementing IO cancellation for basically things that would get requests that would get enqueued and then dequeued. And then, of course, the new driver framework is fully compliant with and implements the cancellation support and makes it very simple as well. Another important thing we did was Nara and I worked up a set of IO cancellation, completion and cancellation guidelines, which are also posted on the web for driver writers. That provide basically a set of requirements that a good driver should adhere to.
So who is NAR?
Narganapati. It's actually Narani. I always mispronounce his name. Narayanan Ganapati. He's Mr. IO manager. He owns the IO management area altogether, and the driver framework.
Okay. Yeah, he's basically the architect for IO. He's my manager. Before I actually started at Microsoft, he had started the implementation for all this cancellation stuff, and then I took over from him, but everything that exists there, he actually added a new thing for Longhorn that kind of ties into cancellation. Previously, all I/O that was issued for like reads and writes, etc., was associated with a thread, and there's a lot of applications, such as RPC applications, that want to issue the I/O, and they have a bunch of Reaper threads that actually want to find out the results of those I/O, and so because they were tied to the original thread, we had to attach back to the original thread in order to properly complete the IRBs, complete the requests. And so he did some work to actually disassociate these requests from the original thread and associate them with the file object instead, which has, under the covers, has implications for cancellation, because when somebody tries to cancel I/O for a thread, we have to look at all the file objects that previously existed for that thread and make sure we cancel that I/O as well. Now all this is done transparently to the user, but it's something that at least driver writers need to be aware of, the fact that not all these I/Os are going to be associated with the thread anymore.
So what are the things that developers can do to help this cancellation along?
So if you have, I'll just talk about, I guess, a couple of the guidelines in a general sense. If you have application developers really can't do anything about what the drivers are doing. If the driver doesn't support cancellation, they can try and cancel and hope that the driver completes the request quickly. There's not much else they can do. But if you're a driver writer, on the other hand, and you know that you have requests that are going to maybe take an indefinite amount of time because they're blocking up, waiting on user input, or they're going to maybe take a long time going across the network, the onus is on you to support cancellation using either, as Gerald mentioned, the cancel safe queues, rolling it yourself, which is susceptible to many race conditions, or using the new driver framework, the Windows Driver Foundation. There's plenty of stuff on that on the Microsoft.com Windows Hardware and Driver Central website. It's Microsoft.com/WHDC. Anybody who's interested in more about cancellation or the new foundation, etc., should definitely check that site out. There's lots of interesting articles there. So if your driver does support cancellation, you want to use one of these different mechanisms, and if you know that maybe your driver will take a long time once in a while because of hardware failure, and every other time it's really quick, then that's not something we're looking to drive down to. I mean, your hardware fails. We're looking at the case where every single time your I/O can take an indefinite amount of time or a long period of time. We want to make sure that driver writers know that they need to provide this support in order to unblock people from clicking that big red X and sitting there for 5 minutes while it closes.
On the test side, one of the difficulties of this is that cancellation in the past has tended to be almost an edge case. Generally, cancellations only occurred when an application would actually terminate or close down. And what that meant was that since it was a very infrequently occurring situation, people tended to give it short shrift in terms of test. one of the things that we've been very concerned about is ensuring that the test teams really develop their own test mechanism to really thoroughly vet out these cancellation paths. So good code coverage is really essential. The other thing is that we've developed some tools now to make it possible to do it. Previously, we didn't have any tools to test for completion, excessive completion times and excessive cancellation times, or even the ability to cancel. So we added in Driver Verifier for Longhorn a new option, which we've been calling the Driver Hang Verifier option. That allows you to monitor completion times that exceed thresholds. You can set a threshold, or you can take the default, which is currently 10 seconds. Or also monitor whether or not the cancellation function has been set up, and whether or not, when the cancellation is issued, that it actually does occur within the prescribed amount of time. So these are important capabilities now that exist in Longhorn and are available to you. The nice thing about this is you can test drivers that will work cross-platform, even back to XP and beyond, because if the cancellation is actually implemented, for example, a new create cancel is implemented, if it never gets called, therefore it will never fail. And so for back-level platforms, you can still implement this feature and the support for the create cancellation because it will only get exercised in Longhorn. So it's still safe to do that. So that's one tool. It also has the ability to inject cancellations into your driver or a set of drivers to validate the cancellation functionality.
What's the name of that tool?
It's in part of the standard Driver Verifier facility. Currently, the way you use it is actually you set up Driver Verifier with the IO Verifier option, and then you use the hex 20 flag to define the fact that you want to enable this completion cancellation functionality. And you can use hex 20 to dump out a log of the warnings and that sort of thing that come out.
Okay.
And this is done through the debugger package currently. You have to run the debugger package in order to be able to get this information.
So from a development standpoint, it seems like this would be a difficult thing to test, since it only happens when something happens with a driver or a device. How do you actually go about, testing out your code and?
So are you talking from an application writer perspective, or?
From your perspective.
So basically, we have a kind of a suite of cancellation tests that one of the folks in the kernel test team, Riverala, wrote, and we have one special driver that basically does a lot of things with ERPs, IO requests, pens them, sticks them off in queues, sends them down, and we get another thread coming into the same driver which tries to cancel these ERPs using the various APIs we have.
What does ERP stand for again?
IO request packet. Yeah, okay. Sorry, that's the standard way. That's
okay.
That's any IO you issue to a driver, the information about that IO is transferred to the driver via an ERP. So a read, a write, a device control, etc. The ERP is an internal representation of all the data that goes to the driver.
Not to be confused with Wyatt ERP. Okay.
So basically we have this suite of tests that work on both this special driver, and then it also targets like NTFS and the network file systems, reader and MUP, and issues a bunch of IOs, synchronously cancels them, issues a bunch of asynchronous IOs, tries to cancel them, targets specific IOs, basically takes all the different variations with the new API and the old one that we had, and cancels them on various different drivers that support cancellation, drivers that don't support cancellation, that don't need to support cancellation, make sure that nothing funky goes on there, and it found tons of bugs over the first couple of years when this stuff was running, and getting the driver writers to fix their bugs. I mean, these cases where the bugs were happening were kind of obscure, but that's the whole thing with cancellation. The problems crop up infrequently, but when they do, it's pretty obvious what's happening, and it's pretty obvious what's going to happen when this happens in the field. People are going to see hangs or crashes. So just basically covering all the scenarios, just thinking about the different cases where your driver can pen ERPs where it's not going to complete these ERPs quickly, and trying to target those either by massaging the code by hand or just by going over so many test cases that you're sure everything is covered.
Great. Anything else?
Yeah, one of the things that is going to drive cancellation more into the mainstream, as opposed to being the edge case, is the fact that we're asking developers to support cancellation at the application level. Now, it's often been the case that you know, somebody would pop up a dialog box and for an operation and with a cancel button. Unfortunately, because there was no capability in many cases to cancel an actual create call. Or any other synchronous any other synchronous call that might cancel, or that that might take a long time. In the file I/O space, it would just sit there and get stuck. Well, now people can use these new cancel functionality, the new cancel functionality in the Windows 32 API set to actually implement cancellation at the device level or going down to the driver level. So this is going to become more mainstream as we move forward. It'll take a long time because obviously drivers need to, various drivers are going to need to support this capability going forward. But over time, we expect this to become a much more common capability. Another thing I also want to mention is some work that Jeff did. We took this, what we called ATR functionality that we did way back when, the application termination reporting, which was that ad hoc development that we did. We decided, hey, this is really a gold mine of data. So why don't we build this into Longhorn and into our hang reporting and make it as a standard part of the functionality of Longhorn. So Jeff then took this work and then further developed it.
Yeah, so basically what we did is for Longhorn, if application hangs and fails to terminate, and we will have this capability built into the Longhorn system, and we'll be able to collect this live kernel minidom, which contains the driver, the thread kernel stack, ERB information, pending ERB information, and all other good stuff, which will help the driver developer to see why their driver hangs in the real world. So then we can provide these valuable information back to the driver communities and to the driver developer to let them to understand why their driver is causing hangs or optimization failures. Right.
So how do they go about getting this information or using this?
In order to get the information, we still have a process to work up. This is something that will become especially interesting after we release Longhorn. So we're still working on the details of how the processes are going to work. But it would undoubtedly be through the existing WinQual portal, which is what ISVs and HVs, the software and hardware vendors, have been using in the past. So yeah, we'll be developing that up further. In addition, because the hang reporting is becoming much more sophisticated now, and up until Longhorn has been basically impossible for us to provide good hang reports that are actionable hang reports to our vendors. So to our partners, I should say. So we will be in a position to do that starting with Longhorn because of the new hang reporting features that we've built in.
Great. Well, thank you guys very much.
All right, thanks, Ernie.
Thank you.